All right, let's get started. So we're going to talk about the half-angle identities and the power-reducing identities. Let me point out what we're doing today. Okay, so we're going to be looking at these guys and these guys down here. And really the main focus is going to be on these ones, the half-angle identities. The power-reducing identities are related to the half angles, and you'll see why. But these ones actually, I think, kind of come up more in calculus, right? So you're more likely to kind of see them this way in calculus. But if you've got the half angle identities down, if you thoroughly understand those, then these are kind of you kind of get these for free. But that will conclude, that covers everything. The only identities we haven't talked about are these periodic ones. I mean, we have talked about those. We just talked about them when we were doing graphing, right? Because we talked about how all of these functions are periodic. But we've talked about everything else except for law of sines, law of cosines. That's something that's going to come up later on. I think it's in chapter 7 or chapter 8. Anyway, so let's talk about these half-angle identities. So once again, I'm just going to prove one of these to you. Actually, we'll prove another one together as an exercise. But let's start off. Let's prove that cosine squared A is 1 plus cosine 2A divided by 2. Okay, so this fact just comes straight from a double angle identity that we covered in 5.5, right? So remember that for cosine 2A, we had three different options for how we could express cosine 2A. One way that we could do it is we could say cosine 2A. So one of the formulations for this was that this was going to be 2 cosine squared A minus 1. Okay, so this is an identity that we have. We've proven this to be true. We talked about this one yesterday, or well, in 5.5, right? Anyway, so you can just solve for cosine squared A and you end up with this thing, right? So you add 1 to the other side. And then divide by 2. Right, and there you go. The other ones are similar, right? So if you want to show that sine squared A is 1 minus cosine 2A over 2, you can do the same thing. You start with cosine 2A equals 1 minus 2 sine squared A. Right, so cosine 2A is 1 minus 2 sine squared A, and then solve for sine squared A, and you end up with 1 minus cosine 2A over 2. And then tangent, of course, is just sine over cosine. So so if you want an identity for tangent squared, well then you can just say it's this one over the one that you get for sine, and you end up with the identity for tangent, right? So so that's no big deal. This is a power-reducing identity. I call these ones power-reducing identities because it takes you from the square of a trig function to a trig function raised to the first power. And these things will come up a lot. I think especially probably in your second semester of calculus, when you're doing a lot of integration, learning a lot of integration techniques, you'll use these power-reducing identities a lot. But these things, like I said, are really, they're really closely related to the half-angle identities that are the main topic of discussion in this section. Because, so note, if we make the replacement theta equals 2a. So if we replace all the 2a's there with thetas, then we would have to replace a with theta over 2, right? If theta is 2a, then theta over 2 is a. And if we make those replacements, then we get this. So then we get, cosine squared of a, which is really the same thing as theta over 2 now, right? Theta over 2 equals 1 plus cosine 2a, which is really theta, divided by 2. Okay, and now if you take the square root of both sides, then you get cosine theta over 2 is plus or minus square root of 1 plus cosine theta over 2. And now that's the half angle identity on your identity sheet for cosine theta over 2, right? So all of these half angle identities that you get from that you get on your identity sheet, they all come from the power reducing identities, right? By making that substitution and then solving for, by making that substitution and then taking square root, right? One thing that I'll say about these half angle identities is that they require you to decide whether you should take the positive or the negative square root. And of course, you're going to make that decision based on where theta over 2 is, right? So in the case of cosine, if the angle we're looking for here is in quadrant 1 or quadrant 4, then we're going to take the positive square root. If it's in quadrant 2 or 3, we're going to take the negative square root, right? And then, of course, we'd make different decisions for sine and for tangent, okay? Just depending on where those trig functions are positive and where they're negative. So I'm going to walk you through a couple examples. I might start a new video, okay, to start walking you through examples, but I've got several here to kind of show you how to apply these things. Okay, so I'm going to start a new video, and then we'll look at an example.